Greetings all, Ferrari 601 here. A little bit of something different for you today. You are looking at a Wilesco D22 model steam engine. Now, those of you who have seen my channel for some time, you do know that I, in addition to being a very enthusiastic sim racer, I am also a collector of model steam engines. I love engines of all kinds, obviously, because I love cars, but for me, steam engines are really intriguing because they were really the first iteration of mechanical power generation, as far as we know, throughout the whole of human history. So steam engines, for me, are really where it all starts when we start talking about automobiles and modern technology in general. The steam engine was what started the Industrial Revolution, and that obviously changed the way the entire world worked forever. In fact, all the way up through today, steam engines are what generates most of the world's electricity, at very least here in the United States, but some form of steam engine is most likely providing you the electricity at this very moment so that your computer works or your phone works and you're able to watch this video. So yeah, steam engines, although we consider them to be somewhat antiquated technology, and they certainly are, they're well over 200 years old now in terms of their most basic design concepts, but they are still quite relevant in today's world. Here we have a model steam engine, and yes, it is a fully functional steam engine. It actually boils water, turns it to steam, and converts that thermal energy via heat and water and steam, and of course a bit of pressure as well, into rotational mechanical energy so that it's able to do actual physical work. It's a really cool thing, and we're going to take a little look at it. This particular engine, as I've already mentioned, is a Wilesco D22. It is made by Wilesco in Germany. This is the third Wilesco engine that I have owned. Those of you who have seen the channel before, you might have noticed two review videos I did on my Wilesco D20 and D455. Those are also stationary model steam engines, both fully operational, and they are absolutely awesome. So I liked those two engines so much that I decided to go for a third one, and I wanted something a bit different. I wanted a twin-cylinder model, and here it is. This is a twin-cylinder steam engine. Yeah, it looks pretty cool. It definitely looks pretty cool, and I thought so too, so I said, you know what? Let's just bite the bullet and buy it. Yeah, they are a little expensive, but they are really, really cool things. And Wilesco, for the most part, really good quality products as well. So you really cannot go wrong when you buy a Wilesco engine, and certainly that's the case with this one as well. For the most part, there are a couple of things that I will bring to our attention as we progress here, because this one does have a little bit to be desired in terms of its build quality, which was somewhat surprising for me, considering Wilesco made a very good impression on their first two products that I bought anyway. But first, a little overview of this steam engine and steam engines in general if you are somewhat unfamiliar with the technology. A steam engine works by converting thermal energy and pressure from steam into mechanical force and mechanical motion to do work. So the obvious purpose of any engine is to convert some substance or some state of matter into a usable state that is then applicable to a utilitarian purpose, really. A steam engine works by heating water in a boiler, which is this part right here. This is the boiler. Very creative terminology with steam engines. Water boils inside the boiler by means of applying some sort of heat to the boiler. The heat is provided on this engine by a fire. Down here is what's called the firebox. There's a fire inside this box. I know we're very creative here, but there will be a fire underneath here, and that will heat water in the boiler, which will then turn to steam. This boiler runs at an operating pressure of anywhere between, let's say, 0.4 bar all the way up to 1.5 bar. You can see our pressure gauge there. We're on the pin because there's no pressure in the boiler at the moment. Well, atmospheric pressure, but the gauge zeroes at atmospheric pressure, as you might have suspected. But once that water boils inside the aptly named boiler, it is then transmitted out of the boiler through this pipe. This is a steam pipe, more creative names here, and then it is sent over here to the engine. Now, this is a piston engine, and a lot of the parts on this thing may look rather familiar to you if you are familiar with internal combustion engines, because the overall theory of the mechanical motion is pretty much the same. These two cylinders here, we call them cylinders, yep, they're pistons inside here, and they move back and forth quite obviously to transmit that steam pressure into a mechanical force. That force is transmitted through this connecting rod to a crankshaft. So here, the connecting rod that we can see, and then the crankshaft over in this section. That turns that reciprocating motion into rotational motion, and then that rotational motion is what can then do work for us. So it works on exactly the same physical principles in terms of laws of physics as an internal combustion engine, but the difference here is we're talking about external combustion. Yeah, heat and pressure are still involved here, but the heat is applied externally. And that heat is given to us through combustion, which is external to the operation of the engine. So that's why we call it an external combustion engine. But we are still converting heat and pressure into mechanical motion here. So in terms of the macrocosmic physics of this, it's the same idea. As the pistons reciprocate, they will turn this crankshaft and spin that flywheel, which then can be harnessed, and rotational momentum turns into mechanical force, and some reasonable utilitarian work can then be performed. We already talked about the boiler and the firebox and the steam pipe, but of course we've got some other parts on this engine. Here, this little control wheel, this is a regulator valve. This functions as the throttle on this engine. We turn it right, in my direction anyway, to close the throttle, to cut the flow of steam from the boiler toward the engine, so toward the cylinders. And this pipe here is the steam inlet pipe into the cylinder. So this pipe is going to send steam into the cylinders, which will then force the pistons to go back and forth. The means by which those pistons do go back and forth, though, it's actually very, very clever. There are two principal kinds of steam engines. There are single action and double action steam engines, and this one happens to be a double action or double acting steam engine, meaning that as the piston reciprocates back and forth inside the cylinder, it produces power from top dead center to bottom dead center, and from bottom dead center to top dead center. That means that you have a power stroke in both directions. This is not a four-stroke engine, it's not a two-stroke engine, it's basically a one-stroke engine, meaning that every time the piston moves backward or forward, it's generating power, and that power, we see that via torque on the crankshaft. So the piston is forced backward and forward, so you get 2 power strokes for every complete revolution of the crankshaft per cylinder. So that means with these cylinders being displaced 90 degrees apart, you can do the math and figure out that this thing is generating power pretty much constantly. Accomplishing this is valve gear. And yes, just like an internal combustion engine where you have to have inlet valves and exhaust valves, you have the same idea here on a double-acting steam engine, but you don't exactly have separate inlet and exhaust valves. The inlet is an exhaust in one direction or the other. Accomplishing this is a slide valve, and you can see as I rotate the crankshaft, you can see on the right-hand side of the screen, you have the main con rod from the piston going back and forth, but you also have a secondary rod to our left of that main con rod going back and forth, and it's moving out of phase with the main piston con rod. That is a slide valve. The slide valve is run off of the crankshaft, and as it slides back and forth inside this area right here, called the steam chest, this is going to cover or uncover ports that are cast into the steam chest, allowing steam to enter or exit from the cylinder. And there are 2 sets of those ports. There's a port here on the front of the cylinder, and there's a port here on the back of the cylinder. This allows steam to pass into the front of the cylinder and exit the rear, and enter the rear and exit the front according to the piston's position. This means that steam can enter here at this point at top dead center from the top and blow the piston back, and steam can also enter here from this point at bottom dead center and blow the piston forward, thus accomplishing that double action. Of course, because the slide valve moves out of phase with the main con rod on the piston, this means that when the piston is at bottom dead center and steam is entering the rear of the cylinder, the exhaust steam from the power stroke moving toward bottom dead center can now be pushed out toward the exhaust as the piston comes up back to top dead center. So very cool engineering here on a double-acting steam engine. Of course, this idea first came about in the very early 1800s, but Still works today, and of course the idea of having to have valve porting and valves that can move to allow intake and exhaust, that was an idea that was adopted immediately by internal combustion engines, and we all use them every day, perhaps several different types of those internal combustion engines every day. But this is where it all started. Moving around to look at some other parts on the engine in more detail. I mentioned the steam chest here. On top, you'll see this section. This is an oiler. This is what they call a steam jet oiler. When we fire the engine up, we're going to drop some steam oil into these two cups. There's another one, of course, on the other cylinder. And what this does is, well, it does exactly what it says it does. It will shoot oil into the cylinder to keep the piston and valve gear lubricated as they run. You can't use just normal motor oil for a steam cylinder, though. You have to use a bespoke steam cylinder oil because we're dealing with high temperatures and we're dealing with high pressures as well, in addition to moisture. Normal motor oil is not designed to run at temperatures over 300 degrees Fahrenheit, nor is it designed to deal with high moisture. We're talking about steam here, it's water vapor. So normally oil and water don't mix, and oil and water still don't mix when you're talking about a steam engine, but normal motor oil will be washed away by that high pressure steam, and then you'll be left with a dry cylinder, and you're going to do a lot of damage to the piston and the cylinder walls. So you got to use a steam oil in the cylinders at very least. Moving around to the crankshaft area, you can see the crankshaft in a bit better detail now. Here is the main bearing for the con rod from the cylinder. So this is your main rod pin here on the end of the crankshaft. This is where all the torque is going to be transmitted onto the crank. Over here is the linkage for the slide valve. And now this is what they call an eccentric linkage, because this is, as I mentioned, the linkage toward the side valve. But if we turn the engine sideways here, you will start to see why they call this an eccentric linkage. Here's our slide valve right here, and then here is our eccentric linkage. But it's maybe a little difficult to see. But if we go edge on to the crankshaft here, and I rotate the engine, you might be able to see, perhaps not, but perhaps from above, maybe. Yes, you can see that linkage there. I'm talking about this part right here behind the main counterweight on the crankshaft. This part right here rotating around the main axis of rotation on the crankshaft. It's rotating in an eccentric axis to the crankshaft. That's why we call it an eccentric linkage. And what it does is it allows that eccentric to run out of phase with the main con rod and the main pulse of that piston going back and forth, thus enabling the covering and uncovering of those valve ports at the precise correct moment to allow steam to enter or exit the main cylinder and then provide that double action. Pretty cool idea, and of course 100% mechanical. No electronic valve timing here, it's all done with pure physics. The other thing on this engine is we have a transmission on this engine. Now, it is a directly coupled, pretty much 1-to-1 ratio, but you can see here we have two power takeoffs on the crankshaft. We have two pulleys, one pulley here, a small one, and then a larger diameter pulley here, more inboard toward the flywheel. But we have a belt linkage going to this counter shaft at the rear of the plate here where the engine's mounted. This counter shaft is always linked with the crankshaft via this belt. It's really a spring. It functions as a drive belt. A little bit of stretch in it. You can see it does not quite rotate at the same speed as the engine, at least when my finger is just pulling it along here, because there's a little bit of slippage there. But this is a transmission, it's a counter shaft, and Wilesco and some other companies, some other modeling companies, they do sell actual live action models that you can run with these types of steam engines, and you would obviously connect more belt drives to these assorted pulleys on this counter shaft, and then you'd be able to run really whatever you wanted to run. But the engine providing its power to that counter shaft via that spring belt linkage right there. The other side of the engine, it's an identical cylinder to what we've just been looking at, but there's no power takeoff on this side of the crankshaft, just that flywheel in the middle. But same piston, same eccentric, same everything. Speaking of the same, those of you who have seen my video of the Wilesco D455, yes, this is a two-cylinder engine, but the cylinders here, the pistons, the con rods, the valve gear, the slide valves, it's all identical to a Wilesco D455. That's a really good running engine. It actually can reach some pretty high RPM as well. I don't like to run these engines very fast, but it's capable of it, so that means everything is made pretty well. The last couple of controls that we have on the boiler side, all of your operations in terms of running the engine happen from this side, so this is the angle that we'll be looking at it from for most of the video henceforth. However, throttle, as I mentioned, over here, this is a drain valve for the boiler. So right now it's open and the boiler is empty, so I don't have to worry about that. But we turn it right to close it, and we've got to make sure it is all the way closed before we start to fill the boiler with water. Otherwise, we're going to spill water all over the place, and that's just embarrassing and a waste of water. So we're going to make sure that's all nice and tightly closed. Additionally, on top, we have a pressure gauge. We are reading in metric and old school imperial units. So the inner ring, the blue numbers, are PSI, pounds per square inch, and the outer ring, the black numbers, that is atmosphere or bar. So right now we're on the pin at 0. Red line is at 1.5 bar, or about 22 PSI. So that is the maximum safe operating pressure for this boiler. They are pressure tested up to 4 bar, I believe, is the burst pressure on a boiler like this, but you don't want to push those limits. The safety valve, which is this little apparatus right here, this is a poppet valve. This will go off in that manner at about 1.5 bar, or 22 psi. So that keeps us well within a safe tolerance for running the boiler. Over here we have a whistle. When there's pressure in the boiler, we'll sound this and you'll hear what it sounds like. It's very shrill and annoying. And then the last thing that we have to deal with in terms of engine operation is back here. This is a little catch for the condensed water that comes from the engine exhaust. Right now it's all really clean because I've cleaned it out, but the steam exhaust from the engine, from the cylinders, is routed underneath this base plate into this area called the smoke box. Although there's really not much smoke that comes from this engine because I'm burning alcohol fuel. But the exhaust steam will condense back into water. The water will be caught in that little drain catch, and then the remaining steam will be sent up this chimney and then exhausted to atmosphere. So pretty cool stuff, I must say. Now, let's start getting this engine fired up. First thing we have to do is remove our whistle. Nothing is tightened down yet, so it's just easily removed by hand at the moment. And then, after ensuring that our boiler drain is closed, we start filling the boiler with water. So we've removed the whistle and we've put a funnel in its place, and we just very carefully start pouring distilled water into the boiler. This is not a particularly fun or engaging process. It takes about 2 minutes to get the water in there because this funnel is very tiny, but you get the theory. Water's going down the funnel into the boiler. We'll look for the water level in this watch glass on the near side of the boiler. You'll start to see the water level come up in the watch glass, and at that point you'll make the determination when to stop pouring. You're looking for about halfway up the watch glass as a safe operating water level for the engine, and it's just starting to peak up into the lower side of the watch glass now. So we need a bit more water in the boiler before we can say it's full and ready to run, but we're just about getting there. A little more, a little more, a little more, a little more. It's about as exciting as watching paint dry, I am well aware. Fear not. Things are going to get more exciting in a moment. Almost there, almost there. I'm not sure if you can see the water level coming up, but I certainly can. And that's all that matters at the moment because I'm the one in charge of this. All right, that's a safe water level. Let the last bit of water fall out of the funnel. We'll remove it from the top of the boiler, and then we will reinstall our whistle back in its proper position. Gotta make sure you get that in correctly. You don't want to cross-thread anything. We're just talking straight up metal-on-metal contact. You don't want to cross-thread that because that would be the end of your boiler, rather unfortunately. The last bit of that whistle reinstallation that I couldn't show on camera because it's a two-handed operation, you got to tighten it down with a little wrench just to make sure everything is nice and snug. The wrench that you tighten it with is this thing right here. It comes with the engine. It's got 2 sizes, and yeah, it's a wrench, and it actually goes around the side of the whistle like so you can tighten it down if you need to. Nifty bit of kit. I have no idea what size this is. I've never bothered to measure it, but yeah, it's a wrench, and they give you one. Quite thankfully, don't lose it. The next job to do on the engine is undoubtedly the most important one. We have to oil everything. Unlike internal combustion engines where you have either an oil sump or an oil tank, steam engines don't have that luxury. You have to put oil directly on the working surfaces of the engine in order to make sure things are lubricated. And because this is an all-open design, we've got an open crank, open conrods, all that stuff, oil just flies all over the place when this runs. So oil's constantly being used or just flat out ejected from the general vicinity. So oiling these engines is very important. They can starve of oil very easily, and because we're dealing with high temperature and high pressure, it would not take very long for damage to occur. So the first thing that we do when oiling these engines is we add oil to the aforementioned oil cups. They're very small. They hold about one normal-sized drop of oil each. So it's a very delicate operation, very difficult actually to do one-handed right now, but you can just get oil into the cups. And then what we do is we cycle the engine a couple of times to draw that oil into the cylinders. I like to do this a couple of times. I do always oil the engine after a run before I put it away, just to help safeguard against any corrosion, but I have no idea where that oil actually settles inside the cylinders or if it somehow makes its way into the exhaust, so it's always good practice to oil a steam engine before every run, even if you know you oiled it previously. It's just a good habit to get into because they do use oil so much. The other places that we need to oil on the engine are quite numerous, but quite obvious. First, you have all kinds of linkages on an engine like this. So you've got pins coming from the pistons to the conrods. You've got pins coming from the slide valves to the eccentric arms. You've got crank pins over here on the crankshaft. You have eccentric linkages on this side. You've got main bearings for the crankshaft. There are a whole bunch of different contact surfaces, metal-on-metal contact surfaces on this engine, and all of these need to get a generous helping of oil. Here on the main bearings we have little oil cups, so it's quite easy. Just put a drop of oil in there, and then the oil will start to work its way down onto the crankshaft in that bearing space as the engine starts to turn over. The other places, obviously, you need to hit the crank pins on both sides. Double cylinder engine, remember. A little bit between the counterweight and the eccentric linkage on both sides. Just making sure that you hit all of those areas sufficiently. You don't need a lot of oil, but you do need oil there. So once all of that has been hit, in addition to your rod pins for the conrods from the pistons as well as the slide valve conrods. Once all of that has been hit, you're ready for the next phase of this, which is to seal up these oil cups and then to get a fire going. So at this point I have fueled our burner tray. This is the burner tray. I have sterno fuel in here. It is methyl alcohol gel, and I just use a little baking syringe to suck the fuel out of the can and then to put it here, inject it into the tray. So it's just methyl alcohol. Works very nicely. It's very low residue. It doesn't smoke. It doesn't really smell bad. It just smells like rubbing alcohol, because it essentially is. So once you're ready with the fuel, you can then slide your burner tray into the firebox like so, and we'll stop it a little bit short of fully in so we have enough time and enough space to light it. We'll make sure that all of our valves are closed. So the boiler drain valve is closed, the throttle is closed, our whistle is tight, our safety valve has been oiled and it is tight, our pressure gauge is tight, the gaskets are good, and now we're ready to light the fuel. From the moment that you light the fuel on a steam engine, you are a prisoner. You cannot leave this thing unattended for any reason whatsoever. It's less like starting an engine and more like bringing it into life. It's not like an internal combustion engine where things are very controlled. You flip a switch, push a button, or turn a key, and the thing starts. With a steam engine, it's a process, and it all starts the instant that flame is established underneath this boiler. So that instant is right now. Or right now. There we go. Fuel is now lit, and we can slide the tray the rest of the way into the firebox. Checking underneath, I can see that we have a good fire established, and we will be able to start building temperature and pressure in the boiler. From this moment on, I now have to sit here and watch this thing work, which is the whole purpose of making this video anyway. So Looking down here, we can see the fire looks a lot brighter on my camera than it actually does to my eye. Probably the infrared filter on the camera. But you can see the fire is very well established, and we're going to start to build pressure in the boiler. As this is happening, you can go back over here to the engine side, make sure that your throttle is closed, make sure that your oil caps are tight, and check that you have oiled all of your components. We have done that. So now it's really just as exciting as watching a kettle boil, because that's basically what's happening right now. The heat from the fire is now being absorbed into the water in the boiler, and before too long we are going to see some steam pressure starting to build. Over here on the pressure gauge we're still on the pin, but that will start to change presently. Alright, so at this point we can see our pressure gauge is rising. We're just coming up to about 5 psi or 0.2 bar. And that's enough pressure to start sounding the whistle here. You can hear what that sounds like. So that's the whistle. It's very loud and very shrill, and I don't like to sound it because it just sounds bad. But you can see the water is just starting to come to a boil inside that boiler. I know, hard to believe. But now we can also start to open up the regulator on the engine right here and start allowing some of that hot air and steam toward the cylinder, and you can see immediately the engine wants to start kicking over. That's because these two pistons are out of phase with each other by 90 degrees, and that means that they are self-starting. You don't have to flick this one over as much with your hands as you do on the single-cylinder versions of these engines, simply because these engines have a tendency to be self-starting because you've got a power stroke happening all the time on these things. So we open this up, we allow the cylinders to start warming up, and some condensed water is going to be in those cylinders. It will work itself out, but then you can see pretty quickly it starts to kick over. And now we've done got ourselves a good running steam engine. Very, very nice. Right here is a pretty happy running speed for it, and the speed will continue to increase by itself a little bit as things come up to temperature. But just control that speed. You don't really want to go much faster than this because it's just counterproductive. The whole point of these models is to be able to watch them operate, and when these things are going too fast, you really can't see much of anything because, well, they just sort of turn into a blur. But I like to run them at these sorts of speeds, not too fast but not too slow. Very, very nice. And if I be quiet for a moment, you can definitely hear that they don't make a whole lot of noise. They're not loud. People get the idea that steam engines are these loud devices. Not in the least. Actually going to pull the fire here. We're building steam a little too quickly. I've pulled the fire out. There's no longer heat being applied to the boiler, but still running very strongly. Very nice. Just very, very smooth operation. Increasing the revs a little bit. I can feel effectively no vibration coming from this thing. Just lots of very, very smooth operation. The gurgling sound you can hear in the background, that's some of the condensed water in the exhaust being deposited into the condensed water catch, and then the rest of it is being exhausted up through the chimney. Probably can't see it because we're against a white backdrop here, but there is steam coming out of that chimney, and it is functional. Stop the engine for a moment. I want to check the state of everything because we did build steam a little bit too quickly. I pulled the fire out. That's something that you have to do when things get a little bit too crazy. It built steam very fast, faster than I've ever seen it build steam before, actually. So we got up almost to 1.5 bar. I wanted to pull the fire out just to be safe, but you can see here, even with no heat and the engine was running for another 2 minutes, still got about 0.2 bar pressure in there, still plenty to kick it over. So you can see the efficiency on this boiler, but I want to get the fire going again and we'll repressure and monitor everything. But that's what I mean. You can't leave one of these steam engines unattended. We built steam too quickly. Had I walked away for 30 seconds, maybe we would have had a risk of a boiler explosion. So you've really got to watch these things very carefully. Alright, so at this point we have got some pressure back in the boiler. It is coming back. The engine will run at very low pressure. Even at this point, now that it's all warmed up, it should kick over quite easily. So we'll open the regulator again, and you can see it's already wanting to start. Some condensate in the cylinder, give it a little nudge. And there it goes. I have about half a PSI indicated here, and it is running. We'll keep the pressure lower on this run. I mentioned at the beginning of the video that I'm not quite as impressed with the build quality on this engine as I am with my other Wilescos, and there are a couple reasons for this. The first one is that, well, you'll notice here the steam pipe. It's supposed to sit in this little notch. I can't actually point to it right now because this point the engine is mighty hot, but you see the steam pipe coming down here, and then you see this notch on the side of the boiler housing. Steam pipe's supposed to go inside that notch, yet it's not. So that's point one. Point two, the boiler does have a small leak. It is right here at the point where the drain valve connects, and it's an intermittent leak. It does not leak all the time, but sometimes hot water does spray out of here, and it is annoying, but it's not leaking right now, and I don't have an explanation as to why sometimes it does leak and at other times it doesn't. The third reason that I'm somewhat piffed with this engine is the safety valve. The gaskets on top of the safety valve, there's a minuscule slit in the lower gasket on the safety valve, and it does allow some pressure to escape. You see some bubbling up there right now. The only way to fix that is to replace the gasket, and I do have a replacement gasket, but I stuck it on top of the old gasket, and yeah, that's some shoddy workmanship on my part, but I figure 2 is better than 1, and the second gasket on top does take up some of the slack, so it's fine. But I shouldn't have to do things like that on a brand new engine that costs as much as this one does, and I am a little piffed, a little miffed at these things. Fourth problem is it's so inconsistent when I run it. It built steam that time faster than I've ever seen it build steam before, so fast that the engine couldn't possibly use it. So I had to pull the fire and basically make sure the boiler wasn't going to explode. I've never had that happen on any of my other Wilescos, so I'm just a little cautious, I might want to say, when I'm running this engine. It's just a little bit unruly. The engine itself, though, you can see the action. The operation is very, very smooth. It's great. It's another very smooth German engine, as I've been saying in these videos. It's a Wilesco. I've come to expect nothing less from them, but I've also come to expect good build quality from Wilescos, and this boiler just is not there. And it's a little disappointing, I do have to say. But you can see the overall operation of the engine. It's very, very smooth. Even at lower RPMs like this, no problems. We can even slow it down more than this. How's that? That's pretty good. That's really good, I must say. Speed it up a little. It's very, very smooth operation. Some up-close shots here of the eccentric linkages working. Very nice indeed. See the slide valves here on the, what would really be the top of the cylinders, the front of the cylinders. Very, very cool. Try to focus that a bit better. There we go. All in all, very pleasant sounds from this thing. Like I mentioned, they're not loud. A lot of people have the idea that steam engines are loud. They're not. Even small ones like this. Very nice, very pleasant. Boiler pressure here just sitting at about 14 psi. That is well within the safe range, no problems there. Water level is bang on perfect. And the fire looks good. It's not getting out of control. The fire got really big last time, and I'm not quite sure why. It's very, very nice operation. A couple more features of the engine that I should bring to your attention. Because it is a double acting engine, it is of course reversible. So if we can open the taps again, you'll see that it will kick over in the opposite direction. Clearing some condensate from the cylinders, there we go. So it does also run in the opposite direction. It's a little louder in this direction, and I'm not entirely sure why. Maybe something to do with the valve timing, but runs just the same sort of speed. But I do prefer to run it in this direction. Sounds nicer. And of course it is capable of some rather high RPM. We're only at about 10 psi at the moment. But if we open up the taps, you'll see it will rev. I do not like to run my engines that fast. Pretty much this is the maximum speed that I ever like to hit. Just because it's a whole lot more pleasant to watch these things run at lower speeds, and they're really designed to run at those low speeds anyway, but they can rev if you are into that sort of thing. But a lot of people in these model steam engine videos that I have seen, people get critical when you rev these engines high, and I do agree. I mean, yes, it's my engine, I can do what I want with it, but I don't like to rev them high. They're not really designed for that. They will last for many, many years if you take care of them, and one way of taking care of these engines is to make sure that you don't rev the hell out of them, and that's revving the hell out of them. But for once in a while, for demonstration purposes, if you just want to show people what they can do, yeah, open the taps a bit. And there you go. They can rev, but they don't really like it. Steam engines are designed to run at a constant speed, pretty much constantly, so They get happy at a certain rev range and you keep them there. That's when they're most useful. You want consistent power in these things. That's the name of the game, long haul. It's running very nicely here. Safety valve has gone off. 1.5 bar, exactly when it's supposed to. And you can see everything running here very, very nicely. Our transmission spinning away. Operation very nice, very smooth. And we bring it to a stop like so. One thing I will say about these Wilesco engines is these oil cups, you've got to make sure you loosen them at very least while the engine is hot, because the caps have a tendency to seize on the threads once they cool down again. The seals all expand when the temperature comes up, and then it's nigh on impossible to remove them once everything cools back down to room temperature. So just loosen those oiler caps when you stop the engine, otherwise it will effectively be seized solid, so tight are the tolerances on everything. Safety valve lifted and it never came back down, so that's another little niggly thing about this engine. The safety valve works, which is good, but the safety valve never came down again after it lifted when it was supposed to at about 22 psi. So yeah, some little niggly adjustments still to make on this engine, and again, it's a finished Wilesco, so having those kinds of issues on an engine like this definitely, shall we say, non-standard for the Wilesco experience. And you can see I've had to pull the fire out again, and it's building steam erratically. The last run we did, it was very, very fine, very consistent, and then this thing, the pressure shot right up from half a bar all the way up to almost 1.9 bar. Even with the safety valve lifted. So it was building steam far too quickly, overwhelming the capacity of the safety valve. So again, you gotta watch these things when you're playing with them. Yeah, they are technically toys, but the energy in this boiler, when it's at operating pressure, you're talking about a hand grenade, essentially. And if that were to go off in your face, it would not be a very pleasant day. So you do have to watch. You saw the kind of RPM that the engine is capable of reaching. That's steam. That's water that you can get from your taps. That's what you drink. And you can see the amount of energy that is contained in there when you use it in the appropriate state. So yeah, steam engines, that's how they generate power, and certainly this one generates a little bit more power than it can actually use. Of course, the engine's not running under load, but even if it were under significant load, it's still running a lot of steam pressure behind it. So definitely PSA to everybody, be careful with these. Of course, at some point though, there does come a time when you do want to pack it away and stop the run for the night. At this point, the engine's still running strong, still got a boiler pressure of about 0.7 bar. Fire in the firebox is still running strongly as well, so at this point, pretty much your option is to let the fuel burn out and continue to run the engine. So that's what we're going to do for the next couple of minutes. As you can see, everything is still fine. Boiler pressure is good. Oil probably could use some more oil at this point, but we're still probably safe. Considering we're not running at very high speed, we can lower the engine speed a tad as well if we want. You can see how smoothly it does run in that previous little segment. Just wanted to show you some extended running without commentary. But you can see it is a very smooth runner despite some of the boiler issues that we do have on it. There is a little bit of a leak around the safety valve, and there is a little bit of a leak here around the drain valve. But the engine itself It's a very, very smooth runner. I'm very pleased with it overall. I just wish that the boiler was in a little bit better shape. It makes me wonder, maybe the model was dropped at some point. Was it damaged during shipping? Did it leave the factory in a somewhat less than perfect manner? But regardless, here it is, my D22, and it's a very strong runner, as you can see. And I just wish I could get a handle on why sometimes it builds steam so quickly, because it's a little mystifying to me, and it's somewhat dangerous, I think. It really, really makes me want to watch this engine very, very closely, which you should do anyway with the steam engine, but with this one in particular. I've seen other videos on YouTube of D22s, and no one's ever mentioned a problem like that, so maybe I've got a little bit of a unique case here. But regardless, I do have experience with model steam engines. I know what I'm doing, and as long as you do know what you're doing, and you always respect what you're working with, you are dealing with something that is potentially quite dangerous. As long as you're aware of that, I don't think you're going to have any problems. But overall, yeah, it is a good engine overall for what it is. Do I wish it was somewhat better in its build quality? Yeah, of course I do. The boiler is just not quite right. But the engine is a strong runner, as I said, and it is just very cool to watch those two cylinders working in harmony. It really, really is quite interesting. It's my first twin-cylinder engine. Very, very cool. All my other steam engines, my two other Jensens, they're single-cylinder engines. So this just adds some more visual dynamics going on. And of course, it does sound quite different from my single-cylinder Jensens as well. My D20 makes quite a racket when it runs, and of course, it's just a single cylinder. This one, it's a bit smoother. It really is. I am overall pleased with this one. So we have now reached that point where the engine is starting to use steam at a faster rate than the boiler is generating it. You can see the fire is pretty much out now. So at this point, we are going to pull the fire and extinguish it. That's the last end of the firebox still burning there, so we can extinguish that. Fire is out. We'll stop the engine. And at this point, we are going to actually drain the last bit of the pressure from the boiler, because draining this boiler, you use the drain cock, and generally, if it's possible, you want to use the last remaining bit of boiler pressure to help blow that water out. But in this situation, I'm not going to do that, because this the drain pipe is not quite in the right position for me to put a cup underneath it, even if I do work it at a somewhat awkward angle. So I need to tilt the engine over, and it's a two-handed operation, obviously, and I think you can get the idea. You tilt the engine over, and then the water comes out the bottom, and you try to capture it if you can. So that's what I'm going to do for the cleanup. The rest of the cleanup, though, the first thing I've got to remember to do, of course, loosen those oil cup caps. Just back them off a touch. They don't need to be removed, but just so that when the engine cools down, they don't seize in place. Other than that, you can see some pools of oil have collected underneath the crankshaft, as well as underneath the rod pins on the con rod. So I'll clean that up just with some paper towels. And then the last thing I'll do before putting it back in the box is to drop some more oil into the cylinders, just to help combat against any corrosion, because I'm not entirely sure when the next time I'm going to run this engine is going to be. So if it does happen to be on the order of months, which it probably won't be, but if it does, you just want to have some protection in there so things don't rust. I will try to recapture as much of that boiler water as possible, because we've still got about half a boiler full. That's not a negligible amount. And distilled water, it's not very expensive, but yeah, you do have to go to the store to get some more. Of course, I run distilled water just so things don't get all calcified in there. But that's my Wilesco D22. A couple of you did ask if I was still involved in model steam engines. I am, and there's your proof. So hopefully this was somewhat interesting for you, and maybe if you do have a D22 of yourself, maybe you've got some useful tips, especially if maybe you've got some defective boiler parts. But yeah, that's my D22, and it's a little bit of a different thing for the channel. So very, very cool. Little ad hoc video. The editing's not going to be great, I know, but hopefully you've enjoyed it. Until next time, though, for Ironman 601 saying thank you very much, and we will see you soon.